I'm a sucker for punctuality, so we're going to start at 20 past. People are going to roll in, and that's completely cool. It's been a while, particularly with these big speakers. I haven't given a talk in a long time before Cape Town, so I'm a little rusty. You're going to have to forgive me. You know, it's like going back to exercising or training after a long layoff of injury or something. You know, there are muscles that you expect to be there, but they just aren't, and everything is just so much harder. I also have to apologize for the obnoxiously long talk title, but Candace and Rob gave a 250-character limit for talk descriptions, which I felt was completely draconian, and decided to rebel, much like so many other people have. So I think that like the character count per talk has really increased this year. So to begin with, I'm going to have to ask you to bear with me for a second. So let's imagine you are going through your morning routine and you've got a cup of coffee or whatever your beverage of choice is. I know for me it takes at least 2 coffees to kick the engine over. But let's say you go through your morning routine, you grab yourself a coffee, and you start with like getting the gross stuff out of the way. So for me, that's checking email and then Slack in order, like before I can get into the day's work. So you check your email, and then that dread notification appears. Maybe it's from your product owner, maybe it's from your QA, or maybe it's from that poor soul that's responsible for your social media presence or the call center or something. It comes with very little context, but like unbridled condemnation. The site is slow. Panic strikes, and you think to yourself, was it that last release? Did we break something? Was there some kind of regression? No, it couldn't have been a regression. I mean, that was last week Tuesday, right? Surely if there was something wrong, we would have noticed it already. We would have spotted it. Like the dates just don't line up. So then you take to the site yourself, and you're like, cool, well, I'm going to go and hit a few pages, and you go, and in the back of your head, if you're honest, you've got a couple of key candidates that you keep around. You're like, oh, that one's probably the slow one, or you scatter across the site. You hit refresh a few times, everything seems kind of snappy. Hell, maybe you even take a stopwatch or some other timing mechanism to try and figure out, like, are you just imagining it, or is it actually okay? But it all seems fine, right? So then you take to the logs, hoping to find a smoking gun. But your logs are more geared for like functional stuff and exceptions. So you check them, and there are no real exceptions. Nothing really screams at you and stands out. And hell, maybe you decide to chart something, and you take your logs in Kibana and you try and figure out, well, what are the average response times for my service? And there are no standout numbers. Everything looks kind of normal, the same as it did yesterday. And your panic starts being replaced with skepticism, where you're like, I may be looking for a needle in a haystack, and the needle might not even exist. So then you do it. You reach for that tool, right? The one that you don't use very often. You don't really know what all of the options and switches do. Maybe it's expensive. Maybe it's popular. Maybe it's both. But you run the tool, and it spits out a whole bunch of feedback. And you look at it, and like, some of it might be valid. Maybe this is what your users are seeing, maybe not. You're not entirely sure. Maybe it is a problem. So you then, guided by the one tool, go and check your code. You review the likely candidates that either the tool informs or you had stuck in the back of your mind. You make some changes. You put some mitigations in place for these things. Maybe you don't completely trust in them, but the tool said it, so it must be legit. Maybe you even try and write some tests that in a tight loop hammer your system and try and figure out if you can prove that it's slow, right? Maybe you even take this stuff and you ship it to prod because you've made safe changes, you've tested that the stuff still functionally works. So you've done all you responsibly can, right? Right? Sometime later, you have a meeting. Maybe it's hours, maybe it's days, maybe it's weeks. But you have the meeting and you discuss the performance problems. You admit to only being tenuously confident in the changes and are dismayed whenever whoever that product person is says, well, they didn't seem to have a discernible effect, and the feedback is still there. They were problems. You did fix them, but were they the problem? So you do that thing that all developers do when they're backed into a corner. You ask for reproduction steps. It's natural. We all do it, right? Because we crave the determination of, like, you tell me what I need to fix. And the product people look dismayed and concerned, but they listen to you because this is what they've been trained to do. They tell you how the thing breaks and you fix it, right? So they hesitantly write up the ticket or the sticky note or something, and it ends up on the wall and then gets moved systematically to the bottom of the backlog because there's more higher priority stuff that you can work on, right? More things that will add more value to our users. And then in that moment, we all lose, but no one loses more than our users. Yes, this is a little bit contrived, but if I'm honest, this is a meta combination of a whole bunch of experiences that I've had, situations that I've been in over the years, and mistakes that I've made. And if you're honest, and judging by some of the nervous chuckles in the room, you are being a little honest, it is similar to stuff that you've done, right? And this is all normal, because performance is hard. Hi folks, I'm Mike Geyser. I am a Google developer expert in web performance. I don't work for Google, no. What that means is that I'm a part of a community program of like-minded people who care about web performance and talk about some of the intractable problems in the web, growing concerns, how to identify them and how to fix them. I work at a company called Equal Experts. I work as a tech lead there in a performance-dedicated team for one of our big customers in the UK. I have been fortunate to work on a whole bunch of intractable performance problems over the years, and what I'm going to talk to you today is going to hopefully represent some of the stuff that I've learned the hard way over the years. Now, I need to prepare you. This talk contains no magic. There are no silver bullets. There are no golden hammers. There is no single fix for performance that I can teach you. They don't exist. And I think that there is a very real danger of being seduced by your tools because it shapes the way that you see the problem. It convinces you that it knows the answer. Hell, it might even sell it to you. So all I'm going to be talking to you about is a change of perspective and hopefully with that a whole lot of discipline. So let's talk about statistics. I know, I'm sorry, we're going to talk a little bit about statistics. Because one of the problems that we've got as software developers, or anyone that works in technology, is we crave that determinism. For us, we're obsessed with unit tests or test cases or some kind of specification of this is what the problem looks like. And if I were to sum that into performance terms, we want all of the constituent parts of the system to add up. A plus B equals C. And at no point in time, please, at no point in time am I saying that this doesn't hold. It does for a given session. There is no black magic here. And in fact, you can go even further and say when you look at the system as a whole, all of the A's and all of the B's add up to all of the C's. Okay? The system is still consistent. But the second that you do any kind of statistical analysis on it and try and identify the shape of all of the A's and the shape of the B's, suddenly the equations don't match up. Right? And I think this is the change that we need. So I'm going to do a little bit of a caveat here. I'm not a statistician. I'm not formally trained. I have a background, an unlikely background in physics and JavaScript. I know what you're thinking. I know, but it kind of works. And as anybody that knows physicists know that we do really cool things with really liberal assumptions and approximations. So a lot of what I'm going to be teaching you is very pragmatic views of how you can find sophisticated problems without expending much, mental cycle. There are probably more correct ways, and if there is a statistician in the audience, please feel free to correct me. Somebody did in Cape Town. Thanks. So the first thing to understand is that performance is a spectrum, okay? There are users of your site that are going to experience good performance and users that are going to experience bad performance. No matter what you do, they will always exist. That's because there are so many variables that are out of your control. Where they are, their use case, the devices that they're using, the connectivity that they're on, which corner of the office has the worst Wi-Fi, whatever, okay? All you can do is you can change the relative scales of those circles. But it's crucial to understand that. And it feels ridiculous explaining this stuff, but the fundamental primitive that we have to be able to work this out is the histogram, okay? To understand that the performance of your system isn't a number, it's a whole range of numbers from really good to really bad. It doesn't matter what the metric is that you're looking at. And that has a shape. And how we define that shape is by bucketing all of the individual instances of that metric according to a certain width of bucket, right, that they fall into, and counting how many times they occur inside that bucket. Now you can play around with that bucket width, and you can have broader buckets and have these ugly looking staggered bar charts, or really fine buckets and have something that looks like it should be far more precise, right? But the honest reality is that having it be more precise isn't necessarily more useful. The coarser-grained buckets are sometimes more useful for identifying trends, and the finer ones happen at an expense of performance. Ironic, yes. In terms of the stuff that we take a look at to deal with this range of numbers, there are a couple of primitive statistical tools. Like everybody knows average or mean, right? We get taught it from when we were in primary school. And you may know median. Median is kind of the mathematical middle of this data set. And it's not very useful for us because it's renowned for its stability and reliability, which means that it takes a seismic shift in terms of performance to move the median. But that gives you something very useful, right? It gives you the ability to know that if the median moves, it's a really big problem that affects everybody. Average fluctuates quite a lot, but it represents a sort of unhelpful middle ground, not good, not bad, and not really representative of anything. So what we typically end up doing is we start using the idea of percentiles, where if you were to take that range of numbers and you divide them into 100 even little buckets, we start looking at like the 75th percentile. And the 50th percentile would be your average. The 75th percentile is kind of like a higher bound, starting to be bad number that is relatively stable. The higher you go up in terms of percentiles, so 91st percentile or 99th percentile, introduces a whole bunch more variation, a whole bunch of wild and natural variation, and it becomes harder to identify individual trends, but it kind of blows out the signal quite a lot. Okay? Maybe if you've got a very performance-sensitive API, and 99th percentile is really useful to you because it means that you can almost guarantee that this thing is always going to be fast. But in terms of like front-end performance, 99th percentile is just insane in terms of the variation of how your users are connecting stuff. But you don't just look at the stuff in terms of like the bar chart format. That's not very helpful. What you end up doing is once you've decided which statistical functions you want to compare, you do something called time seriesing, which says, well, let's take that then range of data distilled to one value and plot it over time, right? And you get some very, very useful stuff. So you can see on the bottom line where it shows median, it's solid and steady and it doesn't change. And this is very typical, right? It takes a lot to move that line. And when you take a look at like where the mean sits, or the average, and the 75th percentile, you'll see that the one is higher than the other, but the trend tracks very, very closely. And as soon as you go into higher order percentiles, tracking that number over time, you can see that there's firstly a lot wilder variation in terms of the actual values that you're seeing, but that trend line gets blown out massively. Now, in this particular example, it's showing us something very, very useful. Both the average, 50th and 75th percentile, track really closely, right? But at the 91st percentile, we're seeing a disproportionate jump in terms of that number. This indicates that in this problem, it's affecting our worst affected users. And in this case, it was down to CPU time on lower-end median devices. So the data is telling you stuff. And one of the most powerful things that you can do to get the data to tell you stuff is to draw your lines in the sand. Now, it's really hard to do to decide what good looks like what number represents good. And there are some starting points. So I know that Google, for example's sake, has become a lot bolder in telling you what good looks like for certain key web metrics. But it's very useful if you start deciding this stuff for yourself. Like for you, what does good look like? For you, what does bad look like? It doesn't matter what system you're measuring. And then track that over time. How many users have a good experience? Is it going up? Is it going down? Is it stable? Because these things are telling you very useful things that show trends over time, essentially. Now, all we're trying to do is very much like an inverted image. We are wrecking the image. We're wrecking the data in terms of absolute values to try and make certain features pop, right? So that we can see the signal through the noise. And in many ways, playing around with this is more art than science, and you'll find different problems by using different techniques. And they're all essential. But I do hear some of you asking the right question, which is, okay, but how? How do we find these performance problems? I am so very glad that you asked, because I've got this wonderful thing that I'd like to introduce you to, which is the scientific method. Now, depending on which domain you come from, there are so many different sort of dialects and variations of this that are very specific to the kinds of problems they're trying to solve. And this is kind of a redux of the approaches at a high level that we use. So everything that we've covered up until now feeds into the analysis phase, where you're looking at data and trying to identify trends, right? You try and identify the thing that looks wrong that you want to change, because we can't fix something we can't measure, right? The next step that you go into is hypothesis formulation. Once you've noticed a thing, you think of, well, what's this one change that I can make to try and influence that line? This is what we're going to do. This is what we're expecting to see the results as. Then you move into the experimentation phase. And if you're in a place where you've got some kind of A/B testing, some kind of experimentation in place, canary deployments, live A/B, this is a perfect example for it, because you're measuring functionally like versus like code at the same point in time and saying, well, on one server, we're going to make this change and see if that server behaves differently. Or 50% of our users, or maybe like 1% of our users scaling up in case something goes wrong. It's perfect. If you don't have that, it's fine. You can do a before versus after comparison. There are just way more variables for you to control, right? Because it depends on what time of day, it depends on what people were doing, what they were buying, and a whole bunch of other unknown factors, like who deployed what code while we were trying to experiment. So they end up resulting in weaker signals, but it definitely is possible. And then you take that around, and there's this sort of weird loop that happens between synthesis and analysis. And synthesis is taking that hypothesis result and seeing if you can generate more hypotheses from it. And at this point in time, I want to say that like a negative result is just as good as finding the smoking gun, right? Because if you try small things, and if you try those small things smartly, and you disprove it, you can take a whole range of problems off the table without having to resort to like deep inspection and deep issues. Perfect example, does anybody use feature toggling? Right, feature flags? Feature flags at a high level, right, the utmost part of your system, so you can just switch that off in case you need to. The same kind of thing works from a performance perspective. If you can influence the whole arm of a system by toggling something on and off at that point in time, and you don't notice a performance improvement by doing it, you don't have to check any of that code, right? It's clearly not there. That kind of thing. Anyway, this is represented as a nice smooth circle, but it really isn't. It's a lot messier than this, and you go back and forward between phases. So let's just take a brief moment to talk about the problem of testing. So there are two broad categories when it comes to testing, like synthetic testing or real testing, lab testing versus field. And this is basically like Synthetic testing is simulating an interaction with your software in one shape or form. Maybe it's Gatling, maybe it's Lighthouse, maybe it's any of a number of things, right? Purely for the purpose of measuring performance. And the challenge is that some problems cannot be simulated. And if you think about it, maybe it's because your testing data in a tight loop doesn't match real user behavior, so you're falling into like cached database queries that are returning the same stuff, so you're not noticing the same database problems. Or maybe you're trying to measure user interaction delay in the front end, and you don't have a user that's interacting, so you're trying to approximate it, okay? Conversely, the challenge with field data is that you have to instrument real users while they're using the system. And this comes with a certain element of inherent uncontrollable risk, right? You're trying to put code in that's going to measure what people do and slow down that sort of feedback cycle. Crucially, both of these approaches have a place and a time, and they have to be used in conjunction with one another. So I'm briefly going to talk about the observer effect as well, because we've just spoken about instrumenting field data, right? Now, the observer effect in physics is the disturbance of an observed system by the act of observation. Like when you've got an electron microscope, and to see something, we shine light off of it, and you hit the electron moves, so you can't see where the electron is, right? The same risk happens in our performance systems. We put performance code in place to try and measure what the performance of the system is at that point in time, what's going slow, what's going on, and in doing so, risk influencing key metrics that we care about. So this is a very, very real challenge. Like, how do you know you're not moving things and establishing like the wrong behavior? And the only thing that I can say that you can do about that is having multiple layers of measuring the same thing in different ways. Who watches the watchman, right? We have something measuring the performance of the site and something that's deeply instrumenting it, and we compare those two against one another to make sure that they correlate very closely, and the one isn't influencing the system as a whole. So I said correlation. Let's talk about correlation, because everybody loves to have their favorite examples of, you know, correlation is not equal to causation. For example's sake, the peak in ice cream sales and shark attacks matching completely. The challenge is the problem of association, because things might correlate because they're associatively linked, meaning they're caused by the same things. And, you know, where there's smoke, there's usually fire, and often correlation is the only evidence that we have when measuring at a high level to try and identify root causes of problems. How we isolate correlation versus causation is by getting strong signals versus weak signals. So the example that I had earlier where we had the average in the 75th percentile tracking very closely, that was an example of a weak signal. Whereas when we took it up to the 91st percentile, we got a very clear, oh, hell yes, this is something that is definitively a thing. So I had to include this slide because this stuff gets crazy. Because in the late 40s, there apparently was this thing where kids were told not to eat ice cream and not to drink soft drinks because there was a very real fear that it caused polio because the two correlated so much. The association effect was that polio spreads in summer and people like eating ice cream in summer. But it just goes to show there are challenges. Now, this is potentially a contentious point, right? Because people are also obsessed with the idea of having accurate, consistent numbers and representing the full sample set. Now that's good, that's valuable. Having all of the data is good. And just making sure that you don't have massive gaps in your data is incredibly important. But like if you have to choose the two, more data is better than perfect data. Because with more data, you can really blow out those signals and get very strong signals. With smaller sample sets, like you're refreshing the page 10 times, or you're running 100 lighthouse tests in a loop. Those are comparatively small sample sets, resulting in comparatively weak signals. The other thing that's kind of contentious is that I don't think that it needs to be particularly fresh, right? Provided you can analyze more of it. Take all of those logs, all of those performance logs, and ship them off somewhere and analyze them later. Don't throw that stuff away. It doesn't have to be immediate, but you need to be doing some real introspection in terms of that stuff. Because it may make an enormous difference. Now, if this is a hypothetical picture of an architecture. It isn't any particular architecture, but if I'm honest, it's not dissimilar to many architectures that I've worked with in the past. We become so obsessed with measuring that one block, right? And I get it. It's your code, it's your team, it's the stuff that you look after, so that's what you want to prove works fast. But the most important place to measure is from the outside in. As close to your user as you possibly can. Get an understanding of what their experience is, what that number looks like at an absolute level. And then when you see something changing there, don't sort of scattershot all over it. Just do a simple bisection. Try and find the place that's in the middle that's easiest to instrument and measure there. Because depending on what you find there, it may skew you one side or the other, depending on what that number is. And then you can start climbing out and instrumenting between the layers. And that's because performance opportunity exists in the gaps between things. Between your code and the database, between your code and third-party services, between your one microservice and another microservice. That's where you're going to find things. Firewalls, caching layers, reverse proxies. It's entirely likely that each of these will have very specialized sort of logging and analytics frameworks associated to them. They'll ship their logs in a different format to a different place. So you're going to have to learn more query languages, unfortunately. I think I'm at 4 so far this year, and it's April. I'm not good at any of them, right? But I don't need to be. I just need to be able to draw a 75th percentile time series about that data. So the common practices or common approaches that you use to gather these metrics allow you to build some very, very high level, relatively cheap golden thread across your system and draw some very valuable conclusions. Actual tip for people that are working on web development, if you want to do this, you can use the server timing header to return it to the front end, because it can be read on initial document load, and it can be read without influencing the performance of the front end, right? So take your measurements at every single point in time and ship it along with the server timing header, and then you can build that golden thread really, really easily in the front end, including like absolute web data and all of the steps in between that are crucial, and then take that and ship it to your analytics code. You're using Google Analytics or Adobe Analytics or something. So send the stuff there and deal with it later. And there's another, if I remember to get to it, there's another desirable facet of that. But okay, that's just a little trick. Okay. So get your metrics into a common format. It's crucial. You don't need very much. Start, end, and duration. End and duration might be tricky, and you might need to do some smarter things to figure that out at times, but it should be okay. And then try and get it into a place that's predictable. My personal favorite is BigQuery, but I know a lot of people have Elasticsearch around. It does a job, right? Get all of your code into a place where you can, or all of your logs or performance data into a place that you can query it. BigQuery is my favorite because I can just chuck all of the stuff in a Google bucket and consume it at a later stage relatively cheaply. And as we were discussing earlier, performance data is inherently immutable. So you can process it once and kind of leave it until you need to reprocess it because it's happened already. Let's talk about how we usually test stuff, right? You test stuff on your local machine. We like using powerful computers because we need to do powerful things and write awesome code. So we end up testing on our local machine. We run Lighthouse out of our Chrome instance. Maybe if you're running server-side tests, you've got a whole battery of servers that you use to fire Gatling up on. And the challenge is that our users are unlikely to be using either powerful servers or expensive MacBook Pros and are probably going to be stuck on really bad mobile devices, realistically. So whatever you do, try and target the kinds of CPU profiles and performance profiles and network profiles that your users are actually going to be using. Now, a cautionary tale about this. Don't turn the dial too far down, because it's so easy to think, cool, I'm only going to test on 6 times CPU slowdown and slow 3G. But that doesn't mean that it's reflective of your users. And if you turn that dial too far down, like, you're going to find other problems. Things are going to start breaking, but they might not be the problem. They might not be reflective of what your users are seeing. Let's start closing off by talking about the actual hard part, right? Because this is all great, but how do you convince people to invest in this stuff, right? How do you convince people that they should be spending valuable money on performance? Now, there are two broad categories behind this, defensively and offensively. So defensively, you want to spend money on performance because when the site goes down or users crash out, you lose money or you lose functionality, right? But there's also the other side, which is to say that if you treat performance as a feature, you might be able to increase the revenue that you get. You know, users might value it more and use your system. You should be measuring your own data. I think I've made a large enough case for that. The best place for this stuff is typically like analytics data. It's a lagging indicator, but it is an indicator. And start getting comfortable with how your business represents its own commercial data. Like, do you value conversion numbers? Do you value order numbers or like masks, basket size, things like this? And when you start looking at performance regressions or performance changes, match those two together as much as possible. Familiarize yourself with the case studies that match your domain. There are 1 trillion of them. My personal favorite is Deloitte's milliseconds make millions profile, and the only reason I like it is because business people like Deloitte's, right? It's fancy to them, and like when the people that they're relying on driving their business strategy tell them that something as small as 100 millisecond change in front-end performance in an e-commerce space can result up to an increase of 8.4% in conversion and 9.2% in average order value. Those are astronomical numbers in an e-commerce context for 100 milliseconds, which is nothing for web performance, right? So familiarize yourself with the stuff that's going to speak to your business. Okay? Speak to the people that make these decisions and tie them into your hypothesis process. Generate the hypothesis based off of, if we fix this performance regression, this is how much money we can either save or make, either using your own data or the data of others. Now, I do still sense some confusion, right? I still hear some of you asking the question, okay, but how? And I know you want me to dive into the details and tell you, well, this is how. This is how you scientific method, and this is how you fix the performance problems in your system. But I want to pivot that on you and say that what this does and this approach does is it shows you the size, shape, and location of your problems. And once you've found that, you'll find that you actually have a whole bunch of options. Some may not be palatable, some may be. Maybe it's putting hectic caching in place. Maybe it's actually lazy loading that JavaScript dependency that doesn't have to be present on page load. You know? These are far more valuable, and it will then inform how you go about the next steps. And if you open yourself up to it and you still don't know how to fix a particular problem, you've got enough information to ask for help from somebody. You know who to ask, and they can perhaps help you with it. So I think that's me. I'm done. Thank you very much for listening to me ramble about performance. I'm going to take questions, but I'm also going to be standing around at the Equal Expert stand for the rest of the afternoon if anybody wants to ramble about performance some more. Thanks for being an awesome audience. It was a little faster. Oh well. Any questions? Yes. Sorry, just hang fire. We need the microphone so that the people that are on the stream can hear the question.
No problem. I just want to make a small recommendation. You said it's, you don't need a lot of data to store a lot of data. You recommend start, end, and duration. Actually, I recommend strongly you add a fourth one to that, and that is outcome. So, for example, HTTP responses, you can have a lot of really low latency 400s, 500s, but your 200s that is actually returning successful payloads to your responses are actually longer duration. So there can be false distortion there.
100% correct. That's a really, really good comment, and thank you for making it. Obviously, there's more stuff that you probably want to keep. And that's a good point, right? Having the whole spectrum, like HTTP verbs, if you're using them properly, right, and not just making everything a post, it gives you really valuable information. And remember that, like, some of the verbs are inherently cacheable and some of them aren't. So knowing which ones are cacheable and which ones aren't, and which downstream systems are going to cache them or not is really valuable. It's awesome, awesome point. Any other questions? No? No questions? Has anybody been keeping an eye on the Slack thing? Are there questions on Slack? Nope. Okay, well, I give you back 7 minutes of your time.